compete with everybody, especially with the building and all that stuff. So I just switched and pivoted the game mechanic and the way I played to just lean into that advantage of having aim assist. So plug in a controller, try it, don't judge me.
I am not judging. You know what? I am willing to try anything because I am so bad at Fortnite. So tell me, we are here at the NVIDIA event here at Gamescom. What are you most excited about here at the event?
I think it's just the general mystery of what they're, you know, the stuff that they're keeping behind the veil.
The suspense.
They always come out swinging whenever they announce anything. So, as a true gamer, as a hardcore gamer, not that I didn't mean to say true gamer, just as a gamer who's excited to be here, it's always exciting to see what they have up their sleeve and what they're gonna roll.
And we're live. Hi everyone. I can't believe he was scared of saying true gamer. It's like, okay dude, just say true gamer. Let me just lower the volume. Actually no, the volume is pretty low. These people are pretty loud. Like, they should shut up. So everyone, I'm Christian with Cryptic Hybrid and welcome to the best, pretty much the best live stream where we're gonna cover the NVIDIA event in Cologne, Germany. I see a few people have yeah. Well, you know what? You really shouldn't feel sorry about your GPU. I like how that guy from before was saying that. It's like, yeah, the whole mystery of what they're gonna launch. They're gonna launch the new GeForce, the RTX 20 series. It's not big of a deal. So so let's go. Well, let's wait. I guess we're gonna wait. Hey, James. Hello. Let's see what these people are saying.
What's your philosophy when you're building?
I guess it's a developer. Not sure who it is. Sorry.
Possible, or do you like beautiful and simplistic? What's your style?
I kind of just like to shoot from the hip. You know, I really don't work from any like structural plan. I just kind of work from what comes up into my head, and sometimes I'll get.
That's not the. Okay. Not having no structural plan. I mean, everyone has a. Anyway, that's something else. So everyone, this is pretty much just the pre-event interviews. You know that they're. It's. You know, it's to get people excited for the event, which is going to be presented by the NVIDIA CEO. To be fair, I'm really interested in what the RTX 2070 is going to be like, how that's going to play out and how much it's going to cost, because I'm really looking to upgrade, and I'm most likely not going to buy a 2080 or a 2080 Ti just because it's probably going to be expensive, and I wouldn't really I wouldn't be able to justify to myself the cost of that. But for everyone here, you know, please let me know what interests you. I don't know anything about PC hardware. Well, it's, you know, this is the opportunity to learn, because it's really amazing, and it's a lot easier now to get into PC gaming, I think, and PC in general. I think it's teach me. Well, it starts when a baby. No, never mind. No, it doesn't really start with that. You know what? Okay, I don't want to. You know, I would do a lot better interviews than these people. I'm just saying. NVIDIA, next time you do an event, just, you know, invite me and you actually get some really awesome interviews. Just saying. Is everyone dressed the freaking same with jeans and a t-shirt? Really? Like, I mean, really? Well, almost everyone. It's okay. It's okay. You know what? NVIDIA CEO is gonna come out and he's gonna have a leather jacket. I didn't put mine on because you can't see me. I wanted to have a green screen and like actually show myself to the world, but the green screen didn't arrive, and so you don't get to see my face yet. The plan was to show my face and also to wear a leather jacket, you know, to be on the same, you know, wavelength as NVIDIA CEO. But yeah, it's not gonna happen. Not gonna happen because I don't have a green screen. Alright. So this is all in Cologne, where Gamescom is going to start, I think tomorrow, yeah, on the 21st. It's, you know, a game conference, but I mean, hardware is part of that, you know. You need hardware for the game. Be for the game. That's hashtag be for the game.
Well, hi, I'm back.
Shannon, so nice to see you with your...
Doing a secret handshake?
That's a secret.
What are you... Oh, come on. Okay, cringe. Alright, cringe. Okay, this is the cringe moment while we wait for the actual exciting stuff. Yes.
Well, I've met
Sure.
you here,
Okay.
so I was given some tips. I was also given some tips by a gassy Mexican as far as how to play Fortnite, so that's good because you put me in Destiny too, and I
Okay. Talking about Fortnite. This is like it's like what do the kids play these days? Oh, they play Fortnite. Let's talk about Fortnite a lot. It's like, okay, it's not the only game that exists, you know. Freaking hell.
I'm in the top 100 every time.
I feel like you're lying to me.
There's only 100 players at a time.
Well, what a joke. He's top 100 every time. Get it? Because there are 100 players every time on the map. Oh Jesus. Anyway, we should start. Oh, it's already the hour, so we should start soon. I'm guessing they're
Name them, but hiding in a bush the
they're delaying a little bit. But yeah, we should see the GeForce RTX 2080 Ti, probably 2070 announced, with the first two coming earlier. I'm not sure if they're gonna say anything about the 2060 or anything like that. You know, that would be their mid-range card. I'm hoping that they'll say something. You know, at least give us an idea when it's coming. But we'll have to see. The pricing is very important, so that's something that I'm looking forward to finding out.
Can I get it? No, I'm
No.
I'm not
That's a
eligible.
conflict of interest. These are ethics. So you guys can get involved with that. There's
Okay.
ways actually to get involved here on our stream. We're on Twitch. There's a chat.
Oh, so many people saying hello in the Twitch chat. It's like
Questions about specific
no one's gonna reply to you, people. I mean,
fire away. We have the
literally no one's gonna reply to you. But okay. You should come here. You should come on this live stream. You know, if anyone's out there, go to Twitch chat and tell them to go to Cryptic Hybrid, youtube.com/Cryptic Hybrid, because that's where their chat is actually going to be read.
work for NVIDIA who know
NVIDIA doesn't read the chat. It's like we're here to announce stuff. Very expensive stuff that's gonna make us 1.5 billion in revenue a quarter. Only the graphics side. So, you know, reading the Twitch chat is not exactly high priority. You know.
Convention this huge.
Yeah, this is
bigger than like E3.
this is about 3 times bigger.
I don't know if Gamescom is bigger than E3, but anyway, it doesn't have to be. It's not a competition.
People just
It's
attending
not a competition.
wall to wall. People come from all over Europe. This is the
But this is just filler at this point, you know. This is just filler. Like, come on, man. Okay.
demos, but you know what? If you guys are tuned in with us over at our YouTube channel GeForce, you're gonna get to see all that stuff and us getting our hands on.
This is on Twitch, man. Are you actually plugging the GeForce, the YouTube GeForce channel? You're on Twitch right now, dude, too. You know, blasphemy. That's blasphemy. Then again, I am streaming on YouTube and I'm watching a Twitch stream, so,
Yeah,
What? Okay.
yeah.
I'm a little nervous
I
now.
know. We should take a
What
break.
do?
Yeah, no.
Okay.
Calm down. We're gonna take just a little break.
Never mind.
And we'll be back. 70,000 people. Just shh. Goose fraba.
Oh, people are really like, come on, let's start already. I like the audience, so calm. They're like 90% of them are just watching their phones and tweeting out or, you know, doing whatever. Watching porn probably in the back. You know, most of them tweeting probably, you know. Like 60% of them probably took a picture of their lanyard with the NVIDIA logo and stuff and put it on Twitter or Instagram, you know. Which is fine, not berating, I'm just saying. You know, we're just in the waiting phase right now. Just in the freaking waiting phase. Huh. Wow, someone liked the live stream. Thank you for the person who liked the live stream. I hope I'm not gonna get like copyright strike for this music and stuff. I'm talking over it though, so YouTube, come on, don't be crappy, you know. I'm not really interested in the freaking music, so let's lower it even more. Come on. You know, let's start already. Come on. Just go out, leather jacket and all. Say the more you buy, the more you save. See, this doesn't work though. The saying the more you buy, the more you save. Maybe it works in, you know, in the server environment where you say, you know what, if you buy something with 8 GPUs, you're gonna save the money because you're not gonna have to buy a freaking server farm of 28 CPUs, and it's gonna be overall cheaper in that regard. But for gaming, it's like, no, he's still here. Okay, come on, people, start already. Yeah, sure. Yeah, I like this level of excitement. It's like, you're probably going to be this event's gonna blow your mind. It's like, okay, can you show more passion? Nobody's gonna ask any questions. It's okay. Everyone's just saying hello in the chat, so it doesn't matter. It's like, what questions? That's what she said. Ooh, never mind. Never mind. Oh, come on, people, just start already. It's like 5 minutes past. Come on. Okay. Yeah, right. It's like, we're psyched and we're not sure why. That literally doesn't make any sense. It's like, I'm excited but I don't know why. It's like, no, you're excited for a reason. People aren't just excited like for you know, I don't know why I'm excited, but I am. Oh, alright. Starting. Shh. Look at it. Inspired by gamers, built by NVIDIA. Oh, those are the old stuff. Oh, is this like the PC Garage thing? The NVIDIA Garage stuff? Because I don't really... Okay. Okay, this is just filler. More filler. I like how they close the blinds. It's like, if you're a gamer, you always want to be in the fucking dark, and the only light coming from the monitor, because that's the healthiest thing out there. Come on, people. That's not actually happening. Alright. Hey, it's still not starting. Oh, this is actually a Romanian guy. From Lab 501, Mikutsu, I believe. That's pretty cool that he's there.
I'm here with everybody waiting for the amazing announcement that's gonna come very soon. I think we're gonna hear...
Yeah, nice. I've seen him at...
Could it be?
What?
There's so much suspense, I can't wait to, but I am also very, very excited to go to Gamescom as
Fake.
well and see
Fake.
all the different demos that are going to
Sunlight?
be in the room here.
Oh, come on, you know what Sunlight is.
About coming out
We wouldn't be here if it wasn't for Sunlight.
Very interesting things, but this NVIDIA announcement
Well, games.
celebration is definitely one of the most amazing things that are happening in Gamescom this year.
I've been hearing so much hype on the internet, so I am very, very excited and fortunate to be here.
I've heard so much hype, and if you actually read videocards.com, I've seen pretty much everything that's going to be announced today.
Well,
Never mind.
I haven't attended Gamescom before because we are mainly a hardware website, but I have been attending other NVIDIA launches.
Lab 501. It's in Romanian, I think, only, but you can check it out. They have some good stuff there, some good coverage.
Announcement celebration that NVIDIA ever did so far.
Okay, let's lower the volume a little bit because it's just it's still, you know. Well, 142,000 people watching the stream there. Come on, people, just Jesus Christ. I like how they said, like, yeah, it's gonna start at this hour, and then like 10 minutes later they're still talking about oh, we don't know what's gonna happen. We're so excited, but we don't know why. It's like, come on, like, you know, this, yeah.
So I am writing about I am the guy actually testing graphic cards and CPUs and stuff like that before launch.
Alright. Yeah, Lab 501, check them out. Lab501.ro, I think? .ro? Yeah, just Google it. Google it or DuckDuckGo it. Oh, she's so happy. Look how happy she is. That's not fake at all. Nothing fake about the whole setup, no. Oh my god, another...
What you doing out here today in Germany?
I'm here to see the NVIDIA event. I want to see what all the fuss is about. Everyone's Twitter account.
Okay.
And I want to know why.
Yeah, you're in the right place. What do you know?
You know what, see, that's the thing. They should have, like, dyed their hair green. I mean, if they really wanted to be in the you know,
So the extreme
in the game.
PAs have worked. No leaks so far. Everybody's in the
Yeah.
what are you doing?
There's no NDA, everyone's like RTX 2080, RTX 2080 Ti.
Gamescom in Germany.
You know, that's
I know we're gonna be doing some stuff.
the pricing would be interesting to see, like the official pricing.
This whole event, I'm just like, I don't know why I'm here, but I'm here, so.
Well, I'm happy you're here.
You don't know why I'm here because someone paid you to be here. That's why.
So nice.
Mhm.
So, you're
So
also
fun.
here with
So fun.
Spoon, right?
Yeah.
So does Spoon know anything?
No. No,
Perfect.
I'm not kidding. This isn't
No,
like
of course,
a
no one knows
secret
anything.
type thing.
That's what they're supposed to do.
This is how secret
They're not supposed
Spoon is
to
going
know
to be
anything.
hosting a significant portion of this show, and he knows nothing.
Nothing.
Okay.
Nothing at all. I wish
This-
I knew. That'd be cool if I could be
Okay.
like, oh, I don't know anything. But I have no clue.
Yeah, no, I mean,
Oh Jesus. I like how people are still saying hello in the Twitch chat.
so much sense
It's like,
that
okay.
I know a thing.
Yeah, I don't know. I'm hoping. I mean, it's NVIDIA, so it will probably be cool. But
Their graphics cards, obviously, they're cool. I mean, it is a new chip, so that's pretty awesome. The Turing line.
it's a new just
You know, the
card, right? Like
the
specific-
what the GT 102, right? For the 2080 Ti, the GT 104, right? So
if you just like attach
that should be pretty cool.
angles, just had
New chips, I think probably 12 nanometer.
Oh my god, you would.
Then you could do.
I like how people are like, come on, exactly.
Trey, do it right now, before the jet lag wears off and you realize this is a terrible idea.
I'm just exhausted and I'm just loopy.
You know, if anyone played a game,
Speaking of the air,
you know, where they like took a you know,
I love this so much.
drank something like alcohol every time, you know, they heard fake laughter, you would be drunk by now already.
there on the floor, she's found another.
And it's only been like 12 minutes, 15 minutes. We're 15 minutes in this live stream, and if you were doing that drinking game, would have been drunk already.
Here at the event, I have Mike here with me. Hi, Mike. How are you doing?
Yeah, great, thank you. Nice to meet you.
Now, what do you do, Mike? I'm
Okay, I don't know who Mike is.
interested in what you do, actually.
Sure, so I'm a...
Really? Is she extremely interested?
I have my own virtual reality YouTube channel.
Oh, that's
called
cool.
Virtual Reality Oasis, where I deliver the newest...
Oh, that's nice.
news and
Virtual
information
reality.
about virtual reality and gaming.
So, what's your favorite headset?
Oh, that's
Because
cool.
I've tried several of them, and I know what my favorite is.
Yeah.
I'd like to hear it from you.
Just get the Oculus. It's like, what's your favorite? Because I already have a favorite, but I'm just asking you because I'm supposed to ask you this. Because usually people who have a favorite of anything don't exactly ask other people if they have what's their favorite, because their mind is set. So it's like, okay, so what do you use? It's kind of like that, right? So like my favorite game is Heroes of Might and Magic 3. So what are you playing? Like, but yeah.
Yeah, absolutely. Have you tried the new HTC?
Yeah, it's just filler. Frickin' filler. They could have started like 20 minutes later and it would have been the same thing. Hmm.
Well, if you ever need to take any of those off your hands, let me know. I'd be happy to help you out.
Well, you never know, you work for NVIDIA, so maybe we can help each other out.
Yeah, they let me in here for some reason. I'm not really sure why.
Okay.
Mike, thank you so much for joining us. Where can people find you on YouTube?
Virtual Reality Oasis.
He said already the
Perfect. Thank
the
you so much.
channel.
Glad that
Jesus.
you're here with us today. And I'm going to go ahead and throw it back over
Mhm.
to Julian.
very much, Shannon.
Okay, Julian. Who do you have here?
You review games, movies, all that good stuff.
Oh, that's cool.
What are you doing here today?
Well, I'm waiting for the new stuff from NVIDIA. I'm super excited to be here.
Have you been to these NVIDIA events before Gamescom in the past?
Well, not really. It's actually my second time here at Gamescom, so it's my first time at NVIDIA event.
So you have no idea what to expect. You've never seen anything we've pulled out before.
No, absolutely no idea. No one who's there. No one who's there knows anything about what they're gonna announce, and they're all excited without knowing anything.
On right now.
That's exactly that's how humans being behave. That's totally like that's.
Which is powered by the Tegra.
Shh, we're not allowed to talk about that, right? That's an industry secret. No, what are you gaming on your PC?
Right
What?
now, I'm
That's
playing
not an industry secret. Like Nintendo says it.
got released recently.
I think,
I love it.
like in the
That's the tiny
documents and
build, right,
stuff,
where
that
you are
it's a
the
Tegra chip.
keeper that
or like an NVIDIA GPU.
ways to run your graveyard, right?
Correct,
Hey.
correct. It's not that much about being a graveyard keeper. It's more a Stardew Valley meets the medieval kind of theme.
Oh yeah, the Graveyard Keeper. That's a game, and I did a live stream last week, and I think I'm gonna do another live stream this week or maybe next week. Maybe this week. We'll see.
I love to play some AAA big titles when they got released, but I also love indie games.
Yeah.
Yeah, well, that's the joy of being a PC gamer, right? You get to have all those in your world. What card are you using right now?
I got the GTX 770.
Sweet, solid. Keep using
What?
that card.
GTX 770? Okay, see that's the thing is like I have the GTX 770. It's great, solid. It's like a 6-year-old or 7-year-old card or six. Well, let me think. 2 years.
Shannon is out there on
2 years. That's another 4. 6-year-old card, something like that. I mean, wow, sweet. It's like, come on, man. That's not sweet. It's an old card. Hey, no audio. Great production. Oh, now they're back.
Joined by Dennis. Dennis, what is up? Thank you so much for joining us.
Dennis.
Thank you so much for having me.
So, Dennis, tell me a little bit about why you are here.
Well, I'm here with a couple of friends. We're here for Gamescom
Because
tomorrow.
he's
Super
invited?
excited with that. But then also, since today, we've got our new project, which features animation, science, and me as a musician, organ music, and sort of my music, called ODM Project. And we need like a new graphic card because my friend, he's Marius. He's gonna render 1 hour of animation, and that's what we're
Oh, that's
here
cool.
for.
Well, okay, so first off, 2 things. Are you excited about the NVIDIA event?
Oh, yeah, I am so excited for it. Yeah.
Oh, everyone's super excited. I didn't know why.
So really excited to see this one live.
Everyone's super
I'm
excited.
excited as well. But 2, you play organ.
Of course you look excited. Like, seriously, how many times has the word excited been
Oh, cool. I mean, I played a
been
little
said?
bit of ukulele, but I'm not very good. So how long have you been playing?
Well, that's at least 2009 or something. But one thing gets you to another thing. I do video game soundtracks as well. So as a musician,
that's
you
cool.
kind of want to combine things that make yourself interesting. But then, obviously, at the end of the day, that's where you're going to turn up as well.
Well, you know, I really feel like game music, video game music can really influence how the game actually emotionally appeals to you too.
And I feel like this whole thing is going on for a long time and more than it should be.
At the times, yeah.
you just want to keep on playing because it's amazing. All right, so they are getting everybody seated, so I'm going to go ahead and wrap it up. Dennis, thank you so
Alright,
much.
finally, come on, let's actually start this, come on. No, not the
Hello, I
no!
am Julian here with Felix. Now you're a game engineer.
I wanted
in
1070.
correct? So you actually study, how to build games. Have you been following what NVIDIA's been doing, in the recent past with stuff like ray tracing?
I'm new to PC gaming. So what oh, are you building a new PC or are you upgrading?
So many interesting things for graphics. So you
Because a 1070 it wouldn't be a bad card. I wanted to avoid it because I have a 970 and it's like, okay, I'm just gonna skip a generation,
Tech that NVIDIA announced at
But,
GDC last
you know,
year have actually-
it depends a lot on how much an alleged 2070 would cost.
games that kind of fake everything by using some statistical
Okay, you have a 1050, nice. Okay, that will be a pretty big jump then. Cool.
everything in the scene.
That's cool.
The previous best that
Actually, earlier today I was checking out prices for the 1070 Ti. I kind of wish it went down a bit more, really. And then again, nothing has been announced yet. So maybe those prices will go down a little bit afterwards.
and they were starting to do
I don't know, we'll see. Depending on the prices.
really do everything.
Seriously, if the 2070 is gonna be like 500 or something, that's gonna be really crap. Or 450. It's,
actually see the
I don't know, we'll see.
running the RTX stuff at GDC though.
I'm,
It was using 4
the biggest worry for me is the pricing.
cards altogether for like a $60,000.
Because I would really like to upgrade to a
I don't know
20 series card, but
it looks
yeah.
pretty awesome. They bill it as the future of gaming. Felix, thanks so much for talking to us and telling us a little bit about the tech. You guys, we're gonna take a look.
Oh, see? They cut him off. See? He was going to ask a question and they cut him off because the thing is starting. See? They cut him off. Oh, Jesus. Yeah, it's pretty expensive. I mean, it's pretty expensive. Okay, let's go. Jensen, please welcome to the stage, Jensen Huang. No? Oh, they have music on. Music on, but there's nothing really like happening just yet. Come on, people. What do you have to say? Jensen, Jensen, Jensen. He's gonna come out like that's. Is that the thing? Is that what they want? They want people to clap? Because I mean, at least in the front rows, people seem to be pretty meh. It's like, all right, let's just wait here. I mean, we're waiting here. People are pretty chill. I would be actually, you know, more hyped if I was in the front row and stuff, but okay. Come on, people. Put it like a huge green screen. Oh, come on, welcome to the. Oh, okay, great. We're listening to music now. Okay, it's going down. I like, yeah. Oh, okay, 96. Okay, it's starting. Come on.
Technology. I want to incorporate this technology into my art and have the two mixed together.
CGI is poor.
We were making a lot of decisions where we thought things were going to be because we didn't have the compute power to support at the time what we wanted to do.
And we still don't have it.
So at lunch one day, a Bell Labs executive asked, what would it take to ray trace this scene in real time? And I said, well, we need a 512 by 512 array of Cray supercomputers, each with a red, green, and blue light bulb on top, and we'll put it in the desert and fly over it at 10,000 feet and take pictures of it.
I recall it being sort of 10 or 12 months of hell getting these shots done, and it was because the render times are so horrendously long.
Probably copyrighted music.
One, ready, go!
Wait, wasn't Quake in 90... Wait, was this Quake 2? Yeah. The first GPU. Yeah, I remember this tech demo. I actually ran it back in the day. Nalu? No, that's not Nalu, that's, I don't know her name. Nalu was someone else. That was nice. Nice intro.
Ladies and gentlemen, please welcome NVIDIA founder and CEO
Oh,
Jensen Huang.
finally. And president, I think. Right? Isn't he president? Yeah? The more you buy, the more you save. Look at that jacket. Look at that jacket. Ich bin ein Gamer.
First of all, great job, guys. We're gonna kill it. Don't panic. Everything's gonna be fine. There's so much technology in this room right now. It's barely under control. Okay, so you guys are gonna have a great show. Welcome to the launch of the GeForce GTX 1180.
Oh, it's GTX? Ah, he's joking. Oh, he's joking. Alright, I was thinking like, what the hell? Why did he go so fast with the launch? Oh, he's joking, never mind.
I have never seen anything that leaked this much.
Come on, it leaked eventually. It's not, come on, really?
Good news is, you're going to be surprised.
It leaked, you know that.
We didn't do it on purpose, but everything on the web, every spec is wrong.
I doubt
You're
that.
Be surprised.
I highly
It's gonna
doubt
be a
that.
great show. This is a historic moment.
All right.
This is a historic moment for computer graphics. For as long as there has been computer graphics, it has been the dream of computer scientists to generate with computers photorealistic images. When you look at this, what we consider the holy grail of computer graphics, you see some effects that today are simply impossible to create. First of all, light is coming in from the window. It's bouncing all over this room. The vast majority of this room is being illuminated indirectly. Whenever light touches a material, strikes a material, that material is rendered and simulated physically. The material is metallic or dielectric, is either smooth or rough. The roughness can come from microsurface structures that bounces light, absorbs light, diffuses light in a very different way. Maybe it's orientation dependent, maybe it's not. Some of it is glossy, some of it is matte, and as a result, this entire room looks alive. As light is bouncing around this entire room, it doesn't strike every surface the same way. Some of it is occluded from light. We call it ambient occlusion. You also see that there's a desk lamp, and it's shining through the glass, and because the glass has curvature and shape, light refracts around it and accumulates in a way that we call caustics. That little bright reflection on the table is particularly attractive. The shadow of phasma coming from all different directions. It's called umbra and penumbra. Umbra is where the shadow is completely occluded, and penumbra is where it's partially occluded, and so you see the sense of soft shadows. She's reflected in the mirror, even the parts that you don't see. You know how mirrors work. You could see behind things. Oftentimes in video games, we can't do that. The little bit of shadow behind that painting, ambient occlusion, or as light travels through those gummy bears, bounces around inside the gelatin, and then reflects and refracts it back out, called subsurface scattering. All of those little tiny effects are really, really hard to do. And the good news is, in 1979, a computer scientist named Turner Whitted, now a researcher
who's working
at
on
NVIDIA,
NVIDIA,
described an algorithm that was both powerful and elegant. He called it multi-bounce recursive ray tracing. By starting from your eye instead of from a light source where light is emitted, because the vast majority of the light doesn't reach your eyes, so there's no reason to trace them. He traced light backwards, inverse ray tracing. Through the eye, through the pixel, through every single pixel on the screen, the ray would seek out, would be sent forward, and if it were to strike a triangle, it would then send off a shadow ray to decide whether it's in shadow. That shadow ray would go towards the light sources. If there's something else in the way, if it strikes another triangle, it would determine that it was in shadow. And if it doesn't, then it would accumulate the color and the intensity of that light would then be used to shade that surface. If that beam of light, if that ray going through another pixel were to strike a reflective surface, it would generate shadow rays to see if it's in shadow, and it would also generate a reflected wave, a reflected ray, a reflection ray. That reflection ray would be basically the same incident angle relative to the normal of that surface where it struck. And then it would go off and decide whether it strikes another triangle. And if it were to strike another triangle, it would create shadow rays. It would determine whether that particular surface was in shadow or reflection rays and such. And if it was to hit into a surface that is translucent, then it would generate refraction rays based upon Snell's law. And that this algorithm, this basic algorithm, would recursively run. And eventually, he would generate this beautiful image. In 1979, he generated this image, and it took 1.5 hours on a $1 million VAX computer. Basically, he was generating 60 pixels per second. Instead of 60 frames per second, he was generating 60 pixels per second. And so the question then is, how long would it take for us from that time for us to be able to realize this incredibly beautiful picture that I just showed you a second ago? Well, if you look at our technology curve, has been nothing short of extraordinary. And ladies and gentlemen, you have so much to do with it. Because of the extraordinary demand of video games,
play
and
Fortnite,
the scale and the size
Minecraft,
and the vastness of this entire industry, it has propelled one of the most fast advancing technology in the history of computer science. If you look at this curve, Moore's law has been the foundational thought, the foundational idea of computer science for 35 years. And yet during this entire time, since our beginning, we have been moving at 10 times Moore's law. If you go back to when Moore's law was following historical levels of increasing performance 10 times every 5 years, 10 times every 5 years, or 100 times every 10 years, our GPU technology was advancing at 1,000 times every 10 years. 1,000 times every 10 years. And so the question is, and by the way, these are some of my favorite GPUs. Look at GeForce 256. The world's first.
Come on, that was a cool
GeForce.
card.
How many of you had GeForce 256?
Well, the DDR one.
Incredible.
I've never had one. People are lying. Lots of people are lying in there.
Look how cute GeForce 256 is. At the time, so
it was pretty cool.
Time, it was the single largest chip ever built. It was bigger than a CPU, and people were shocked that we built something that big, and they were even more shocked that we could sell something that big. But anyways, GeForce 256. GeForce 3 was the world's first programmable shader.
Tell us the price
GeForce
of that.
GTX 8800 was the first CUDA GPU, the most important GPU we had built up to that time. And then, of course, the most powerful GPU in the world today, the GTX 1080. Well, if you were to plot out this trend and you were to think about how many rays it would take, you had billions of rays we had to send into that room, even though we're not simulating most of the rays, only the ones that are coming into our eyes. We're sending in billions of rays into that room. We've got diffuse rays that we have to do. We have reflection rays, refraction rays, and it's bouncing all over the world, all over the scene. And you have hundreds of polygons, hundreds of millions of polygons. The amount of computation necessary is easily in the several petaflops. Well, several petaflops, we're already at the teraflops today. So it would take approximately 10 more years, approximately 10 more years at our current rate of progress to go from teraflops to petaflops. Well, we didn't want to wait that long. We didn't want to wait that long. And as you know, architecture is the single greatest lever in computer graphics. It is the single greatest lever of GPUs. So what are the interesting new ideas we could create that allows us to achieve effectively 1,000 times more performance 10 years earlier? And so we invented the NVIDIA RTX. The NVIDIA RTX is a platform consisting of architecture and software and SDKs and libraries that allows us to combine different types of rendering technology into one unified and cohesive platform.
Oh, you can't read what that
always
says.
Take advantage of rasterization. Rasterization is so incredibly powerful and so incredibly efficient, but we also need to include ray tracing. However, just ray tracing at brute force level simply won't get us there. It simply won't get us there. And in fact, I'll show you something later that's just really amazing. It simply won't get us there unless we use this technology we discovered about 6-7 years ago called deep learning or artificial intelligence. We can finally create images along with ray tracing that allows us to achieve the levels that we otherwise can't imagine. Now, we leverage two fundamental rendering technologies. You know very well rasterization, which is the way that we do things today. We start with the 3D world, and we take the 3D world information, the vertices, the triangles, and we project 3D world vertices into a 2D world pixel plane, into our screen space. That projection leaves the silhouette of a triangle, and we have to decide and test which one of the pixels are within that triangle. One of the most beautiful things about rasterization is that you could parallelize an enormous amount of calculation, and nothing is more beautiful than being able to do things in parallel. That's one of the reasons why the GPU is so incredibly powerful at parallel processing. It started with the idea of doing things in parallel. It also has the ability to do things incredibly high resolution, because high resolution is just more things in parallel. And so rasterization was incredibly powerful. One of its limitations, however, is that every single time you want to light the world, you have to project light from that light. And if you want 2 or 3 lights, that's fine. If you have an area light, that's effectively infinite number of lights. And if everything in the room were to reflect light, and everything in the room became a lighting surface, otherwise known as global illumination. In the world of global illumination, all of a sudden the number of lights that you would have to cast inside that scene is just insane, and therefore undoable. Well, this is where ray tracing is particularly effective, because ray tracing, using Turner-Whitted's approach, simply traces the number of pixels that comes into your eyes, the number of rays that ultimately reach your eyes. The vast majority of the rays inside this room, the vast majority of rays in the world simply never are reaching our eyes. And so we immediately reject them. We immediately don't have to do them. And we start from ray tracing our eyes. Ray tracing, whereas rasterization is taking 3D world data, projecting it in 2D, ray tracing is sending out a ray of light, intersecting the pixel at the screen space, and enters into the world looking for a triangle that it would intersect. The two basic approaches both has its strengths and weaknesses. In the case of ray tracing, in order to ray trace this entire room, the number of rays, the trillions of rays, the hundreds of millions of polygons, the amount of testing that you have to do just to figure out which ray intersected which polygon is just extraordinary. You simply can't do it. Well,
not yet.
We put this platform together, and we worked with Microsoft to create the DirectX ray tracing, otherwise known as DXR, the Microsoft DXR. And then we worked with Epic to integrate RTX, DXR into the Unreal Engine UE4 engine. And we found somebody with extraordinary art assets, Industrial Light and Magic, and together we created the world's first real-time ray tracing demonstration. It had never been done before. And we announced it this year at GDC, and I think it's worthwhile to take a look at it, and I want to show you something special about it in just a second. Okay, so this is
the Star Wars one.
Our demonstration.
Yeah, it's been seen a billion times already. Well, many times. Still cool, but...
What's the story with all the elevators lately? I heard Kylo Ren destroyed the one over in D sector. If you ask me, who's ever in charge of this place should be transferred to Hoth. What? What? You think she heard us? Yeah.
Yep, she heard us.
At least we blend in for once.
Incredible, right? Absolutely incredible.
It's alright.
And so,
it's alright.
so what you saw was physically based materials. It was sitting in an elevator shaft where there were area lights, and those area lights were moving as the elevator was moving, and therefore, as the area lights would illuminate the surfaces, and the shadows would be soft. The shadows would be soft. Using area lights, and incredibly difficult to render shadows. And notice the inner reflection. There's reflection off of Phasma. There's inner reflection of Phasma on her gun. And there's reflection of her gun on her chest. And if you look at the stormtroopers, the illumination and reflections are all completely in real time. Doing this is simply impractical today. The way that you would do it, of course, is that you would fake a whole bunch of lights. That would slow down performance. It still won't look right, and all the shadows will look bandy. Second, you would create all kinds of what is called reflection probes made out of cube maps. But unfortunately, they're all moving. So every single scene, you're going to have to create a whole bunch more reflection probes, a whole bunch more cube maps, basically starting from the point where you would like to have to see reflection and rendering out from that point every single direction, turning into a cube reflection map. Those tricks simply are not practical with a scene of this level of fidelity. Well, it took 4 Tesla V100s, the same GPUs that are powering 5 of the world's top 7 supercomputers today. It takes 4 of them in a $68,000 deep learning supercomputer that we make called the DGX. This is what researchers use to create their deep learning AI models. And so $68,000 to finally render running the RTX platform, real-time ray tracing at about 20 some odd frames per second. Well, when we announced it, people got so excited about it. They said, how do we buy that DGX? We could use it as a game console.
Yeah, right. Yeah, exactly. I'm sure everyone was saying that. Everybody was so excited to spend so much money for gaming.
How do we turn DGX into a game console? The price point is slightly out of reach for most gamers. And so
slightly, yeah, 64,000.
I would like to make my first announcement.
$6,400 for the whole DGX. It's cheaper. Exactly, yeah, exactly. See, $19.95. Okay, right. Good one. Okay. Yeah. Oh no, 3,000 easy payments of $19.95.
3,000 easy payments. We'll throw in the first game.
You can see the number. 1-888-789-2080.
The telephone number
so they have
right below you. 1-888-789-2080. And
2080, right? 2080.
Good luck with that.
Yeah.
It's beautiful, isn't it? That's just completely liquid cooled. It's silent. Doesn't.
Actually, I don't like the color.
It does real-time ray tracing for the very first time for $68,000. Well, it turns out what you were looking at just now was not running on that. It was running on this little thing, this little bad guy. This is
it's not that little because it's like 754 millimeters square.
Trying, failing, all these different algorithms, trying, failing, and finally, Turing, the most advanced GPU we've ever done, 10 years in the making, the greatest leap since we created CUDA, and computer graphics will never be the same again. Inside Turing is 18.9 billion transistors. This GPU, this chip, is the second largest chip the world has ever made. The only other largest chip is called the V100, which powers supercomputers all over the world. It has 3 brand new processors. The SM is completely brand new, has the ability to do independent floating point and integer operations. And the reason for that is sometimes you're shading for color, sometimes you're using integer operations to calculate addresses so that you could run your shader program to do things like subsurface scattering. And as more and more special effects are to happen, the SM's address calculation part of the logic becomes much more complex. 14 teraflops and 14 integer operations per second. I like to shorten it just to 14 tips. So 14 teraflops and 14 tips. It also has the ability to do this thing I won't talk much about today, but we're going to write plenty about it, variable rate shading, so that we could do things like foveated rendering, focusing all of the horsepower of the GPU where your eyes are focused instead of wasting it evenly across the entire space. If you're moving, we might be able to adapt the place where we focus your shading horsepower. If the resolution or the content detail is different across the entire scene, as most scenes are, we could focus our horsepower where there's the greatest amount of fidelity. As a result, you're effectively getting a several X boost in your shading performance. The second,
I'm guessing that would be good for VR games.
Processor we call the RT core. RT stands for Ray Tracing Core. It's 10 gigarays per second. I love saying that, 10 gigarays per second. A 1080 Ti, the fastest GPU in the world today, 1080 Ti does 1.21 you guys got, no? Nobody ever saw that show? 1.21 gigarays per second, okay? And so we do 10 gigarays per second, which is 10 times a 1080 Ti. It does I'll explain that in just a second, a BVH tree traversal, and it does ray triangle intersection testing. And then we have a new processor called Tensor Core, which runs AI processing like crazy. 110 floating point teraflops, or because it has multiple precisions, depending on the type of networks you're running, you might be able to use lower precision or mixed precision. As a result, 440 tops with 4-bit integer. All of this so that we could do hybrid rendering and run RTX. Well, so the question is, how does this all turn out? So if you look at the performance,
can it play Crysis? That's the
Turing
question.
Is built for RTX. And if we ran, the first thing I showed you was originally ran a GDC was DGX with 4 volts, 55 milliseconds. 55 milliseconds, about 20 frames per second. And this is what Turing looks like. 1 Turing. So 4 volts in a DGX.
I'm guessing the RT cores are very important there, right? It'll be really interesting to see how that works.
This has never happened before.
Works.
This has simply never happened before. Doing computer graphics, essentially a supercomputer replaced by 1 GPU within 1 generation. Of course, it took us 10 years working in parallel. If you were to look at Pascal, this is what Pascal looks like.
Like 200 or something? Oh, 308
milliseconds.
The
fastest GPU on the planet. The fastest GPU on the planet today. 1080 Ti, 308 milliseconds versus 45. Basically, about 8x. So the question is, what's happening under the hood? This is a new computing model, and so there's a new way to think about performance. It's a new computing model, so there needs to be new metrics. Back in the good old days, the vast majority of computation was done in shading. We're basically shading the color, or we're running a program in the shader, and basically we're shading. But in the future, we're going to be doing lighting, we're going to be doing all kinds of image processing, and so the pipeline is completely different. And if a pipeline is different, the platform software's got to be different, the architecture of the GPU has to be different, and you have to measure it differently. We have a new way of measuring, and let me talk to you about how we're going to do that. So if you look at this frame, this is abstracted, of course, but it's not too far off. Basically, within the frame that I was showing you earlier, we're doing ray tracing pretty much all the time. Okay, we're shooting rays all over the place. We're looking for intersections of triangles.
Because there's an RT
which
core.
one of them has to generate shadow rays, and which ones of them have to generate reflection rays, and which one of them has to generate refraction rays. And for the reflective rays, it's got to figure out how many more shadow rays it's got to generate. And so all those rays are bouncing all over the place, and eventually we accumulate the color, the intensity, whether it's directly or from something nearby, and we shade that surface. And so we're ray tracing all the time. And that's with our RT core. That's the amount of time, the fraction of time within 22 milliseconds that an RT core is doing it. Imagine if we didn't have the RT core, multiply that by 10. If we didn't have an RT core, that green bar, just simply in terms of time, is just 10 times larger. So basically, all the way down the street. Shading is shading. We're doing shading incredibly well. One of the things that's really great about Turing shader is that we can now overlap or run independently floating point integer, and as a result, it's, call it 1.5 times more performant than it used to be. And then that's the integer shading there. And then for DNN processing, when everything is done, we could use it to generate pixels
deep learning
that we haven't finished. To generate using artificial intelligence the pixel that we haven't finished, or use artificial intelligence to generate resolution that we otherwise couldn't have. Okay? It is possible to filter information, but it's very, very difficult to generate new information that looks right. And so with artificial intelligence, we can now, for the very first time, generate missing pixels that are actually right. And we could do it in real time because we have the tensor core. And so if this is what's going on in the frame, then what's happening inside our chip? So the first part of that processing, the shader and the RT core, the Turing SM and the RT core are both concurrently running. Later on, we're shading and running other parts of the program, the shader program. And so those two parts are running, the FP and the integer. And then finally, when everything is done, we're going to use artificial intelligence. All of our 110 teraflops. 110 teraflops, think of that, is basically 10 1080 Ti's. It's basically 10 1080 Ti's dedicated to doing one thing, which is artificial intelligence. And so if
that's
you
quite
just
a bit
simply
of
do the
die
math,
space.
you have about 14 teraflops.
Kind of looks like it's like a quarter almost. Well, maybe not a quarter, maybe
110 teraflops effectively
maybe 20% of the size.
Ray tracing. 14 plus 14 independent teraflops and tips, and then lastly 110 FP16 tensor core processing floating point operations per second. When you take that and do the weighted average on it, it's basically 78 tera RTX ops per second. And so the way to think about performance in the future is to figure out a way to weight all of these different types of processors. And so the way we think about Turing is 78 tera RTX ops.
That's CEO math probably.
Okay. Compare that to a Titan X, our highest end of approximately,
which doesn't have a tensor core, which doesn't have the
78 versus 12.
Yeah. The RT cores.
Ray tracing.
Yeah.
That's what it's going to look like. 78 versus 12. Well, one of the most important miracles, you're going to see a lot of writing about this in the future, is simply the testing. The concept is simple. You're sending an array into the scene, and you're trying to figure out which one of those triangles out of 100 million that intersects. Well, you could simply just walk across the screen and see which
through
one
all of
you
them
eventually touch.
Yeah.
Well, you got to go 100 million times. Or what you could do is you create a data structure, an acceleration data structure called a bounding volume hierarchy. Basically, it's like binning. Suppose I had 10 things I got to figure out which one is the one I want. I was asked to go pick something out. I had to go pick one of 1,000. I'm going to put 10 bins or 10 boxes, and within each one of them, I'll have 100 things. Within each box, I'll have 10 boxes with 10 things each. If I knew that, as I started looking for that thing out of those boxes, and I discovered that it is in one of those larger boxes, then I can ignore every other box. And then once I find that within the larger boxes, if I find it within one of the 10 smaller boxes, I can ignore all of the other boxes. And then if I can find it within that box, I know it's one of the 10. It's the same idea here. we're sending this triangle, we're sending out this ray, we're trying to figure out which one of the triangles it intersects with, and once it intersects with a bounding box, which is a large structure, which has a whole bunch of other bounding boxes within it, which other boxes within it, and within that there's a whole bunch of triangles. Once we intersect one of the bounding boxes, we know all the other bounding boxes are ignored. And then we figure out which one of the bounding boxes within, and then once we figure out which one of the bounding boxes within, we have to figure out which one of the triangles it happens to be. Well, the amount of mathematics necessary to do this is just shocking. And to do it precisely so that the image quality is perfect is really, really hard. And took us 10 years to do this. To create the architecture and the algorithm for doing this, design it in a way that actually speeds up, which is very, very hard to do because these beams, all these rays are incoherent, which is the enemy of parallelism. Somehow, we figured out a way to make all these incoherent things largely parallel, and then to create an acceleration structure, an accelerator that allows us to do this at the speed of light. And so, the RT core was invented. Well, the RT core invention had to go along with all the software layer on top of it and what we call eventually the RTX platform. At SIGGRAPH, we were really pleased to see research being done in this area. Our researchers and the researchers at the Search for Extraordinary Experience, I love that, SEED, Electronic Arts research team. NVIDIA research is called NVIDIA Research. EA research is called SEED. I love that. The Search for Extraordinary Experience Division. And so they worked on
how much money are they
RTX
investing in that? Come on.
With our researchers to figure out how it could accelerate, how it could create new computer graphics. And everything from deferred shading and direct shadows and lighting and reflections and global illumination and ambient occlusion, transparency and translucency. Translucency and transparency are just incredibly hard to do with rasterization because the concept of depth is very difficult to discern. And post-processing, as you could see, for each one of these operations, we're using different parts of the chip, exactly as I described earlier. The effective ops, the effective computational capability, 6 times Volta. 6 times Volta, 6 times NVIDIA V100. And so that kind of puts it in perspective. This new Turing processor, this new Turing GPU is just a monster. It's incredible. Let's take a look at some of the stuff.
Size-wise, too.
So this is what it looks like. This is computer graphics today. Physically based material, direct lighting. You could see the shadows. They're hard shadows. We could try to trick it by blurring it a little bit, but it's still going to be basically that. And this is what RTX looks like. Okay, so.
Okay, someone told him to clap, right? I'm pretty sure. For sure someone told him to clap. Come
you
on.
got to clap at the old stuff too because, you know, it resembles us. So, here we go. We'll give you a chance. Guys.
Yeah, right. Yeah, clap
This
was
is where we
like
came
a few
from.
polygons
You gotta be
in.
proud of it. You got to own it.
Yeah.
It's ugly, but you got to own it. Before, after.
And after.
Before RTX, after RTX.
I like people say like 3
No,
balls.
this is
right?
just the
Like, come on.
beginning. I'm just warming you guys up. I just gave you an olive for the appetizer. Okay, can we show them some stuff? Nacho, is it you and me?
Feed us.
Yes.
Okay, so this is Nacho. He's one of our dev techs, incredible computer scientist, amazing computer graphics engineer. This is what he was able to do with RTX off. RTX off. Now, of course, this scene is incredibly hard, and the reason for that is because you can't use tricks like screen space reflection here. You could put some reflection probes, but it's just incredibly hard here because things are being reflected all over the place. There's refraction. You see that graphics card back there? That's a beautiful graphics card. I announced it a week ago. That's called the Quadro RTX.
Yeah. Yeah.
And you got this crystal ball here.
So you use the same chips.
Where it should reflect and refract. There's a little green ball on the ground there, and then there's that chrome ball in the back, and this empty, I don't know why, but empty glass box.
Tank.
And it's got area light coming in, which is really hard to do. Okay, and so in this particular case, Ignacio is doing his best to emulate the area lights, but the shadows are ugly. You know, this is the limits of today's computer graphics. Now we could fake a lot of
shadow
stuff.
shaming.
We could fake a lot of stuff by arting it up and cause you to not look at it. But in the final analysis, this is what the limits of today's computer graphics is. Now, Ignacio, let's turn RTX on.
People got it like, yeah, we're supposed to clap like right away when we see the new image.
So let's take a look at RTX on. Look what happens. The refraction of the glass globe there is just incredible. And look at this, the little caustics on the ground. The area lights cast a soft shadow. The umbra and the penumbra, notice of the graphics card. The shadow of the chrome ball looks right. Now there's reflection of the glass box in the RTX, Quadro RTX. You see Quadro RTX from that sphere, and you see the reflection of the chrome ball with a little bit of rough surface to give you a sense of material. Everything just kind of looks right. Even the glass is casting a shadow. Even the glass is casting a shadow. Hey, let's go back to the last one again. Yeah, I know. Now, of course, we got to add a whole bunch of paint and a whole bunch of stuff to make it look right. Or we could do it this way. RTX on.
And you only need $500 at least to get this. Really?
But this could possibly be a photograph, right? Nacho, show me what you got.
Technically. Oh, you can move around.
Come on.
Yeah.
Okay.
You can manipulate it.
Pretty incredible. You had to turn on a spotlight on top of that. Everything just works. Everything just works. Look, glass reflects and refracts and magnifies just like it's supposed to. And you just have to turn it on.
I
the benefit of RTX.
No, about the reflection of the light from the crystal ball, but okay. Maybe.
And so now I'm going to show you something. We're going to turn it on together. We're going to put it all in. We're going to put it all together. And it's going to be a demonstration that we created recently. To highlight the power of NVIDIA RTX, this mixed mode rendering, unifying rasterization, ray tracing, compute, and artificial intelligence. And what you're about to see is completely in real time. Everything you're about to see is completely in real time. It's kind of hard to grok because it's going to be so beautiful, but it's completely in real time. You're going to see beautiful reflections. You're going to see inter-reflections, reflections of reflections, and it's all going to be dynamic. You're going to see beautiful lighting. You're going to see area lights. You're going to see beautiful ambient occlusion. You're going to see beautiful physically modeled materials. So things that look like metal looks like metal. Things that look like things look like things. That's very technical. And that's how I talk to the engineers. Guys, we got to make things that are things look like things. And they go, I know what you want, boss. And so what's in here is just really a miracle. And it's running on one Turing GPU. It's running on one Turing GPU. Ladies and gentlemen, the name of our demo is called Sol, S-O-L.
Okay. Sol as in sun? Oh yeah, so this they've shown this one at the That's SIGGRAPH. Needs more green. Too much light blue. Needs more green. Pre-rendered, yeah. Yeah, the robots are having a party. Jesus. It's funny. It's supposed to be funny. Oh, busted. Actually, nah. Wow. I think that's one of the guys who's I think that's one of the guys who are the new male cheerleaders in the NFL.
The NVIDIA RTX. NVIDIA RTX running on top of a Turing GPU. Hybrid rendering, real-time ray tracing for the very first time.
Unreal Engine 4.
That's the first.
In Unreal Engine 4.
Deep learning is the single most powerful computer technology that has come onto the scene in the last 30 years. Deep learning is a field of machine learning where using a large amount of data, you could train a supremely large neural network how to do things. You train these neural networks with all of this massive amounts of data, which is otherwise example.
People are saying deep fakes
on supercomputers. And this is the reason why voice recognition, natural language understanding, photo tagging, image recognition, all of these amazing feats of software are now finally possible. It is the reason why self-driving cars is even within reason to fathom. Deep learning is changing one industry after another. And people consider this the fourth industrial revolution. It is going to enable AI and computers to write software by itself, to basically run on a supercomputer, to write software by itself. At NVIDIA, we're doing all kinds of research around deep learning. We have a gigantic supercomputer that all of our researchers use to develop software. Now, some of the things that are, I'm showing you some examples here. These are some of my favorites, but there's so many. For example, you could teach a neural network how to colorize by just showing this neural network examples of, this is a black and white, this is how you colorize it, this is black and white, this is how you colorize it. It eventually learned what the pattern is, and you can give it a black and white image, and it colorizes it. You could teach a network how to take a low resolution image and make it higher resolution. Because you and I could look at this image and say to ourselves, you know what, I bet I know what pixel each one of those pixels are. And so you could use a low resolution image input and eventually get an output of a high resolution image by going the other way, which is starting with a high resolution image and give this neural network the opportunity to generate that, and whenever it's wrong, you correct it using this thing called stochastic gradient descent and backpropagation. And so you literally correct it, and it tries to guess and guess and guess, and it corrects itself until one day it's able to figure out what pixels to generate. You could teach it how to take a cartoon and turn it into live video. This is a piece of work that we did in NVIDIA research. Okay, we simply taught it how to do that. Pretty amazing, right? We could teach it to take a low-resolution CT scan and not only increase the resolution of it, but also segment it, figure out what organ is what from that blurry blue image. Okay, you watch this? We taught it how to segment, how to identify which organ is what, and put a different color around it. Pretty amazing. This is going to revolutionize
That is actually pretty
imaging. We
amazing.
have a platform called Clara. It has the ability, you could teach it how to go find identical twins. Come on, you guys, that was funny. I don't. This is what we taught it to do. Change the color of the hair. All in real time.
Hey, Instagram filters. All that processing power
Previously, you would
just
have
to
find
see how you look in a
identical
different
twins
color.
To do that. Much harder. Now you could do it with a artificial intelligence network. You could take a sketch and turn it into 3D. So you take this neural network, you give it a whole bunch of examples, you tell it what is the input and what is the exact expected output, and we give it a chance to try again, trillions and trillions of times on a supercomputer. Eventually, it trains and does this amazing thing. And then it creates this neural network model with hundreds of millions of parameters or hundreds of gigaflops of operation necessary to perform its task, to either classify, to predict, to draw, to generate, to imagine what color looks like. We could teach it to do these amazing things. However, there are so many architectures, and it takes so much processing to do it in real time. And so we created this thing called a tensor core. There are a whole bunch of them in our chip. And imagine this, okay?
Well, did they actually create them, or didn't Google design the tensor core?
11 teraflops. A full 1080 Ti. A full 1080 Ti at $699 is 11 teraflops.
Right.
This is 110 teraflops. Basically, it would take
and that's going to justify the new car costing more.
Tensor core processor that's all over the Turing GPU. Now, one of the things that we taught it to do is something really incredible. And so we taught.
So expect more than
$699
$699 for the
we're
new
calling the
die
NVIDIA
card.
DLSS, Deep Learning Super Sample. Basically works like this. We create a whole bunch of super high resolution images with lots and lots of samples. So we jitter it and we create basically 64 amazing images, and we create hundreds of thousands of those. And then we give our network, we put an image in here, and we say, using this, it's called an autoencoder, convolutional autoencoder. It has to be temporally stable because we want to do this for live action. And so the network has to remember part of the past. And we're going to give it an image, and we're saying, go generate this amazing image on the output. Okay? So pretty soon we'll be able to give it a new image it's never seen. We train it, and every time we train it, if it guesses wrong, we tell it what's the right answer, we propagate it back. It takes another image, it guesses it again, and if it turns out to be wrong, we propagate it back. And we sit there and we just simply loop on it on a supercomputer. We run it trillions of times. And then eventually you put in an image and it creates this beautiful image out. You create you take an image of lower resolution, say 1440p, and it creates this beautiful image that's 4K. Now, of course, the question is, where did the images come from? Where did that come from? Where did that magic come from? It came from partly a supercomputer. Essentially, what deep learning is doing is codifying the memories of a supercomputer, and it puts it into this neural network, basically an image generation brain. and you put this image generation brain, this neural brain, into the mathematics of our GPU, all of a sudden, it knows when it sees this image, a better version of it is that. And it sees a new image, a better version of it is that. That mathematics came about, the weights of those neurons came about because of a supercomputer. And so in the future, every game would have had the benefit of supercomputer pre-processing before you play it. And we call that platform the NVIDIA NGX. In the future, computer graphics will merge with neural net processing. We call it neural graphics acceleration, NGX. It's a framework for doing all kinds of amazing image processing. You saw earlier super resolution. We've invented super slow-mo. We're going to do all kinds of amazing things that makes video games and the images that come out of these computer graphics, CGI, look even more amazing. Basically, it works like this. We have a supercomputing infrastructure. There's a whole bunch of software that runs on it. The first thing you do is you generate ground truth. What is the perfect image? What is the perfect image? And then we have to train this model. It's a multi-dimensional manifold, and we're basically randomly walking around this manifold looking for the least error, looking for the time when you send in an image, the output is closest, your predicted output is closest to what ground truth is, okay? That your prediction is the closest to ground truth. And you're sitting here wandering around this gigantic universe, and it's incredibly, incredibly large. And so the computation time is very, very long. And that's why we build these supercomputers we call DGX. I showed you an earlier version, the desk side version with 4 GPUs. These ones have 8. And then we test and optimize it. Then you put in a low resolution image or lower quality image, or the image is in fact not even complete with ray tracing, and somehow we complete it. Somehow we make it more beautiful. The NVIDIA NGX. And then we have this AI model that we then OTA to you. You download it into your driver, into this plug-in interface called NGX, and the neural networks are changing all the time. They're getting better and better, and we put it up in the cloud, and you could decide whether you want to enhance your images or not. Then you run that on Turing. NGX, driver, this is all part of the RTX platform, and you run it on the chip. Well, the supercomputer looks like this. This is the machine that is generating all of those networks. And basically, before you even run it on Turing, before you even run your game on Turing, there are a bunch of supercomputers here's one. There's a bunch of supercomputers that's training these models. And the graphics card.
There's nothing in it. There's nothing in it.
The graphics card.
It's going to actually take.
You guys know what a graphics card looks like, right? Here's one.
Yeah, that's not the graphics card.
Available retail.
No, that's not.
$68,000.
No. Yeah, that's not the graphics card.
Okay.
I don't know why they call it that. Like the world's biggest, the largest GPU ever created. Well, it's a bunch of GPUs connected.
Bunch of interconnects, SerDes interconnects called NVLink, connects all of these GPUs together into one virtual GPU. Every single GPU can see each other's GPU memory. All together,
yeah, that's pretty cool.
This board, that system has 2 of these inside. 2 of them. This is 1 petaflops. That's another petaflop, not motherboard, but mother of, God, it's heavy. GPU, 2 graphics cards, makes 2 petaflops. 2 petaflops, you want to put 2 petaflops is basically a supercomputer with servers from that side to that side. 400 servers, $2 million without anything else of servers this replaces. And so we use this to train the neural network model. Here we go. Here. You can do it. Thanks, Lyle. Thanks, Paul. You use that, and you train this network called the NVIDIA DLSS. Okay? And then it comes up with a model like this, and this is 4K TAA. You guys know the Unreal Engine Epic's demo called Infiltrator is just beautiful. incredibly taxing on systems. And 4K TAA up there. TAA is the anti-aliasing technology we invented, which is temporal. And so temporal, it takes last frame, the motion vectors, and it tries to figure out what's the best combination to create beautiful edges. Look at that, because it's temporal and the motion vectors, so many things are moving. You see a disjointed hinge over here. And this is 4K DLSS. Look at this. That's just perfect. Okay?
Well, yeah. Perfect. Yeah, okay.
Well, for the very first time, because of this, because
close.
we could take a lower resolution image, and because we could train a neural network with all kinds of super high resolution and super high quality images, this neural network,
so this has to be per game,
runs on
probably.
a bat out of hell processor called a tensor core, could then in real time enhance images. In real time generate pixels it had never seen before. Generate pixels that make sense to go there, because if you and I were to look at it, we would know what makes sense to go there, and therefore it makes sense that we could teach a neural network how to make sense of what pixels to put there. So I'm going to show you something. This is Infiltrator running on one GPU
Turing
at 78 frames per second in 4K at a quality that has never been seen before. A 1080 Ti, the fastest GPU in the world, can currently do about 30-something. Okay, from 30-something, what you're about to see is 4K. Now I'm going to lock it to 60 hertz because this display happens to be V-synced. And so you're going to see the frame rate on top, and ideally, it's pretty high. Very first time to see Infiltrator running at 60 hertz in 4K.
At 4K. Okay, so I'm guessing this would be like, you know, how in the NVIDIA control panel, the GeForce experience thing, you can tell, yeah, optimize my visuals. I'm guessing it's gonna be something like that, and you'll be able to get certain information provided from the cloud, you know, on per game, right? Per game, and it's like, well, if you have this game, then you know, do something like that, and your local graphics card is gonna make the computational stuff. Alarm! Alarm! Oh, so the frame rate is in the upper left. Okay, 60, 59, okay. Genji. So this is Genji.
Is that amazing? It's just silky smooth. Silky smooth. One Turing GPU, twice the performance of the highest end GPU in the world today, 1080 Ti, running at 4K with beautiful image quality. Well, you know, we should probably at this point take a look at what Turing does and RTX does for games. You guys want to see some games?
Yeah, obviously. Well, I'm guessing a lot of people were here for the graphics cards, but okay.
You need your mic on, sir.
Oh, testing 1, 2.
Yeah,
okay. So,
ladies and gentlemen, Keita.
All right, so first up we have...
Head of our developer relations. We work so closely with developers all around the world. We work with them to improve new technology, create new technology, and optimize their games for our platforms, and push the limits of what's possible in real-time computer graphics. And the work that we all do together is it just brings me so much joy. And we got this amazing developer relations teams that works with them, and dev tech team, and all these computer scientists that work with them. And man, it's just so great. I love you guys.
In my 17 years here, Jensen, our entire team has never been more excited over a new technology, a new product than with Turing. And also with the developer reception has been phenomenal, and we're just so pumped. It's really an honor to be here to
people would say like
deliver.
4K
You know
Roblox.
what?
Roblox, yeah.
I'm going to give every DevRel and every dev tech in our company a new Turing.
Oh my God. Oh.
Yeah, which one? Yeah, like they can't afford to get one. Poor people. Like probably like $50,000-$60,000 a year at least.
I'm sure has increased by a factor of 10 since I said that. Okay, what's the first game we're going to talk about?
So Shadow of the Tomb Raider is the first up. It's the latest and the really obviously not much needs to be said. It's a super successful franchise. Just data-wise, it sold 65 million units, and it's going to ship the Shadow of the Tomb Raider on September 14th. This time, the game has
Let's see
Laura
how that
Croft
sells.
going on an epic adventure in Mesoamerica and South America.
Did he say Laura
Just
Croft?
one thing to note, a parallel.
Laura?
Laura has a
No,
long
it's
and
Lara
illustrious
Croft.
history. And actually,
Laura?
in many ways, Laura
He's
and
saying
I have
Laura.
grown up together because we both.
No, it's Lara.
Never thought of it that way.
Yeah, in the mid '90s.
Yeah.
And in fact, Jensen, it happens to be the first game I played when I bought my first Riva 128 in 19.
I was 30 when she was 25.
One.
Grew up together.
So yeah, so we work for Crystal Dynamics, Nixies, and IDOS Montreal, and we're excited to be able to show it.
And now what we're going to feature, we're going to show just a little
Yeah.
part of it. Then later there's an after show, and there's the developers are going to talk to you about all this. You're going to be able to see all this stuff. But we're going to show you just a few
You'll
things
see more
about it.
Laura
So one of
Croft.
the things, of course, Laura Croft, you're in shadow all the time. It's all about shadows. And
Laura.
one of the challenges
Laura.
with shadows, as you know, they're just using traditional shadows. They're too crisp. And so they have these hard shadows, and if we use contact hardening and we use percentage closeness shadows, they're kind of blurry and fuzzy and noisy, and when you put a whole bunch of them together, it just becomes a big mess. And so what you're looking at is ray trace shadows. And you're going to see a lot of ray trace shadow stuff, and that's the first demo we're going to show you. We're going to feature ray trace shadows. Go, take it away, guys.
Okay.
Hey. My name's
Chad.
Hey, I'm over here. And apparently I work in the DevRel team with Kata, and apparently I just got a new Turing, so I'm really excited.
Bingo.
So what we did is we worked with Nixies and IDOS Montreal to bring real-time ray-traced shadows to Shadow of the Tomb Raider. It's perfect.
And so the thing to look at right now with RTX off, you saw the crisp shadows up there, and you saw right here. This is really hard to do, and that's why they don't do it at all, which is dynamic lights and shadows.
These are dynamic point lights. They're really expensive to do in current rendering techniques because basically you have to cast shadows in every direction from the light. And this goes back to what you were saying earlier about having to put a cube map here and a cube map here, and every time you move, you have to redo all that rendering. So let's put RTX to the test and have it just do it for us.
Aww. The beautiful thing about ray tracing is you turn it on. You know, when you turn on the light, it just does the right thing physically. And because we're tracing these rays physically, it should perform according to what we expect.
Yeah,
and so the umbras, where right behind, where it's nice and dark, it's correct. And where penumbra, where you have the softness of the shadow, because not all of the shadow is occluded, part of it is lit, you get some softness.
They can't seem too soft at times.
Wow.
Like
now let's take you to, you were
kid
talking
on the
about
left.
some of those area lights earlier. You want to look at some examples of those?
Yeah.
Well, here's a big example. This is an incredibly lit scene. This whole scene is amazing. It's beautiful. And so what we have here is we have two cone lights and two area lights. Those area lights are basically rectangular shapes, the neon lights above the stage. And what you notice is the shadows below are hard, like you keep talking. And this is state-of-the-art for real-time graphics right now. And I got to say that because the guys are sitting right next to me who made those shadows. And they are, Brett, this is the best we have right now.
And they look beautiful.
Yeah, they look great.
Until now. And the way that's simulated, those area lights are simulated essentially as a couple of point lights. And that's why you see such hard shadows. But if you simulate the area lights like area lights, because we ray traced it, and independent of where the rays bounced around, eventually, if it were to hit some part of that area light, it gets lit. And so ray tracing is a much more cost-effective, in fact,
it's
however,
lit.
very difficult to do way of doing area lights.
And let's turn this on and take a look. So you get the nice blend of the color and the light.
Isn't that beautiful, guys?
It's rather.
And we can do whatever we like. We could add more area lights. We could add more spotlights. You can mix it all together without trying to fidget with it, without trying to figure out what is the definition of right. Right just looks right. That's another wisdom. Right looks right.
And talking to the artists that do this, they tell me all great things about shadows. They're telling me shadow is another color to them. They love shadow. And they also told me that shadow and light is what they use to set the mood and tone of their environments. And so that's how important shadows are. And it feels like we just gave them a lot more depth for it.
Very interesting to see the impact of RTX.
Okay.
That's going to be one big thing when the game comes out.
We want to take a look at some
To
more
see the
area lights that are
performance
very
impact.
interesting. Kind of
Yeah, let's take a look at one more shadow.
All right. One more shadow.
Oh! What the hell? One more shadow, press F.
That right there, that's
Press
the
F
umbra.
to... Okay.
You want me to turn it on?
No, keep going.
Sorry.
And that's the penumbra just now.
Okay.
Okay? You see, that's
Okay,
the penumbra.
we're back.
No, keep it off. Keep it off.
Okay.
Yeah, see, that's the umbra. And notice how sharp that is. That's just not right. It should fade away. Okay.
The
turn
chat
it
is
on.
not showing.
There you go. There you go. Otherwise, it looks like another person on the ground. Look
Nah,
at that.
the chat isn't
contact
working.
hardening.
Alright, so let's... Sorry. Just try to refresh here.
The umbra works. The penumbra works. Everything just works. Okay. All
Okay,
right, man.
it's back.
Good
People
job,
refreshed,
Chad.
yeah. Good, yeah. Okay. Good.
Guys, let's take a
Okay,
look
can
at
we-
an
can we
exclusive
switch
trailer
back?
of the Shadow of the Tomb Raider.
Can you switch? Okay. Laura Croft, look at her. Laura, look at Laura. Hey, look, it's Assassin's Creed. But yeah, that will be really interesting to see, and that's one thing that I'm really interested in, to see the performance numbers, RTX on and off in Shadow of the Tomb Raider, on obviously the same card, the same configuration.
That's awesome.
Become the Tomb Raider, become Laura Croft.
I can't wait. That's going to be a wonderful game. All right, what's up next?
He's not gonna play it.
Another
Oh,
blockbuster.
he took off his
and
jacket.
this time
Wow,
we
that's
have Metro Exodus
jacket
by
off. It's
4A
hot.
Games.
It's lit.
Oh man.
Yeah.
This thing is lit. Okay, see, this one should look really
So
good.
for those of you,
Let's see.
who don't know, it's the third in the Metro series. This is set to take place in
Yep.
2036 in the post-apocalyptic wasteland of the former Russian Federation. You guys know this. It's been super successful. In just 2 versions of the game, they've sold 7 million units. And this one, Metro Exodus, is due out February 22nd of next year. It's going to be well worth their wait. It's developed by 4A Games, who, since for the first time we met with them, Jensen, back in 2009, they're super enthusiastic and very forward-thinking, so we're not surprised that we have them here today to show something awesome.
Yeah, that's really cool. Now, the thing that we're going to show,
Yeah, they've
we're
really
gonna
been
showcase
pushing
with this
for
demo
visuals,
here
you know?
is something that is just really, really hard. Basically, the way light works is, can you guys see this? My light is really bright, but basically, light is coming in from the outside through those windows. And of course, this part is lit directly. And the challenge here is that's an area light, and so we have to make sure that the shadows look right. However, that light doesn't stop there. That light bounces around this room, and it illuminates different parts of the scene, depending on how close they are to that particular light. And maybe in the creases and the corners it's really super dark, but in other places it's more light, and direct light it's completely bright. And so lighting this room using traditional computer graphics lighting is just incredibly hard. And this is the perfect showcase for global illumination. Now they want to use light, of course, to create these incredible moods. And so you feel, you know, a little scared when you walk into a room, instead of being completely black, which is not right, or completely lit, which is not right either. And so global illumination has the ability to create an aura, a feeling, a sensation that is really photoreal. And so this has been something that we've been pursuing literally for a long time. This is a 10-year pursuit that we have finally been able to do, global illumination. Let's take it away. So Matt, this is GI on, and so just as I was describing earlier, the light is coming in through the window, it's bouncing around inside, and as a result, we're lighting, look at that, that corner is darker, that corner over there is completely dark, and that light right above the windshield is nicely lit. It does exactly what you expect it to do, and it does it all by itself. Just put sunlight outside. Super high intensity ambient light. Put it outside and everything just works. Everything just works.
Put it outside. Put it outside. Come on.
No, go to direct light.
Yeah.
You see this?
Mm-hmm.
This is the way computer graphics basically works. Now, of course, we could create a whole bunch more fake lights. But in this room, if you create more fake lights using spotlights, you'll get all these different areas that are lit too intensely and others that are not, and it looks like you basically turned on a whole bunch of lights. Now, what you could do, and what Matt did earlier, is turn on basically a artificial global illumination light, which is basically a fake ambient light. It's like somebody comes in here, and instead of allowing us to light this room with global illumination, which is happening right now from these monitors, like for example, I'm being lit by the monitor, and you guys are all being lit by this screen, this 4K gigantic, beautiful screen. And so the entire room is being lit with indirect lighting. But here, because we can't do indirect lighting back in the past, as in yesterday, we had to put a fake light in here. It's like somebody comes in here and put a fake light and constant intensity, constant color throughout this entire room. As a result, the places that should be dark, like back there, isn't dark. The places that should be more bright is the same intensity. Okay, which is what you're looking at now. So this is wrong, and let's look at right. Look at that. Delightful.
Right. Yes, the more you buy, the more you light, the more you save.
So
the
Matt,
more you light, the more you see.
Our friends are now able to have like creepy monsters literally squatting in the corner.
Yeah. Take a look in the rafters in the ceiling. When RTX is on, they're black. I could hide anything in there. But if I'm lighting it ambiently, you can see everything up there. When we have RTX on,
what would you like to hide
There's
in
no
there?
light up there, so we can actually hide things in. We can make the mood and the environment perfect
like what?
by just letting the normal light in the room.
Games will never be the same.
No, sir.
So scary. All right, good job. Thank you.
Well, yeah, if you put a monster in there, it's going to be scary.
Let's take a look at another exclusive trailer, shall we? Metro.
All right, let's see this. This should look good. Because Metro always looks good.
That is incredibly scary. I don't
I
think
think
we have
people are getting
arrows.
bored in there.
Okay, I'm going to flash through a couple of them, and then in the after show, we're going to show it to you. I want to save time for a whole bunch more stuff. Okay, let me show you. Assetto Corsa.
Like actually
Competizione.
announcing the freaking... It's competizione. What are you saying? Come on. You know how to pronounce it.
I spoke 2 languages today already.
Jesus.
Okay, when you guys see it later, I want you guys to look at some stuff. Okay, first of all, the reflection on the windshield. You guys know how screen space reflection works. If it's not on the screen, there's no way to take that image and reflect it onto the surface. And as a result, look at the glass on top. You see that car? You see the Ferrari up there? It's reflected on top. All of the rails all the way down are reflected. No errors, no weird banding, no weird distortions. You see this guy reflected from the other side. So when you go see it, he'll be moving and everything will be dynamic. When the cars come through, you'll see all the reflections up and down this aisle of the cars.
Yeah, because you're going to look at the freaking reflections while you're driving the car.
Everything is completely
You know,
dynamic, and nothing had to be tweaked.
you go 200 kilometers an hour and you're going to look at the freaking glass to see if your car is or other cars are reflected.
If you look at the railing, the shadows are just rendered beautifully, the soft shadows.
I mean, it's cool. I'm not saying it's not. I just like, you're not going to watch. You're going to have your eyes on the freaking glass on the side.
And yet, for ray tracing, it just works. In fact, if you see the final game, the other way, the shadows of the last buildings are completely gone. You're going to see reflections of the toolbox of the garage and the car in the garage. Everything just works. Global illumination just works. Ambient occlusion just works. All of the soft shadows underneath the cars just work. And you can look through the window, and depending on the angle of your view, you'll see Fresnel reflection. So sometimes you see perfect reflection. Sometimes you'll see through the car. Everything just works because ray tracing just works. You're going to see another game called Atomic Heart. And this game is just really interesting. And it's got wonderful reflections and refractions. And mirrors are curved. Curved mirrors. Nobody does that. It's impossible. Not for ray tracing. It just works. You get this area light underneath, casting that soft shadow for the robot behind it. Everything is physically based. All the materials are rendered beautifully. And so area lights, reflections of the scene that you can't see in the scene. So screen space.
It's $1,000 and it just works. Mm-hmm.
Well, guys, I want to show you something that's really cool. You guys want to see an amazing game?
Because that wasn't cool.
I can't wait for this. This is probably one of my family's favorite games, and this is wow, guys, I can't wait.
Oh, Battlefield. Okay. Okay. Yeah.
I think
someone said Cyberpunk. Yeah,
this
is just
Jonas
Cyberpunk.
and Christian from DICE, guys.
Hello, Jensen. Hello.
Some of the brightest and the most amazing computer graphics engineers in the world. We've been working together on implementing RTX into Battlefield 5. Now, you guys, the anticipation of Battlefield 5 is so great, I don't think I need to introduce what is the concept of Battlefield 5. It is a World War II FPS. It is part history, part travel, part time travel, part running for your life, part destruction, real-time destruction. You've never seen destruction.
Part
like
reimagining history
right,
by today's
you guys
lens
know
and
destruction.
ideology. Yeah.
You guys know how to blow it up. Okay? There's mayhem. There's chaos. You work as a team. You can
Just
battle
show
by
it.
yourself. I want to go learn all kinds of stuff about World War II by going through your game.
Yeah, you're not gonna learn stuff about World War II. Yeah, that's not gonna happen.
God mode and go through as a tourist. So we're gonna show you some pretty
if
amazing
you want
stuff.
World War II, you're not gonna play.
That's right.
Okay, Jonas, let's go. Take it away.
Yep, Christian.
All right. Thank you, Jensen. Thank you, NVIDIA, for hosting such a great show. This is really cool. I'm Christian. I'm a tech director for Engine Group at DICE, and next to me we have Jonas, media and video editor. We're here to show you our implementation, our vision, our take on what RTX can be, and we want to show that in our brand new Battlefield 5. And in the setting, we'll take a look at our brand new multiplayer map, Rotterdam. And it's a really dense and cool city map. We'll start here in a very zoomed-in view of the soldier's eye. And we're going to observe something that we've never really been able to do before. So
what, making eyes look like glass?
I worked closely with NVIDIA.
Because it looks like that.
Over the past year to get to the point where we are now. And we're so proud and thrilled to be here and show it off to all of you. So, Jonas, I'll leave it to you. Take it away.
Yeah. So, what you're seeing there is a tank firing off screen, being reflected in the character's eye.
Now, you guys know this is not possible with screen space reflection, right, Jonas?
Exactly. This is
because the fire is not
You know, that's not possible with reality.
Now, if we turn around and we then see the environment, we can see that the tank muzzle flash not only reflects in the eye, it reflects in the entire environment in the tram windows there and within the tank itself.
Yeah, because they're all super shiny and reflective.
Now, if we keep moving forward, yeah. Great. So of course, one of the big
these are the
challenges
shiniest
of the
cars
are
and
complex
eyes ever.
surfaces like this. So now with RTX on, if we set off an explosion behind the tank here, but next to the car,
oh come on,
reflecting accurately within the car.
That's impossible. How would you do that with RTX off?
Yeah, how does that look? Like this here. So let's,
Wow, that looks incredible.
And it's, of course, it's updating dynamically, everything.
Reflections will never be the same again. Look at the reflections off the ground, guys. It just.
Yeah, so you can see.
Wow, it just happens.
With SSR, if it's in the screen space, you still get some of the reflections upon the car, but due to the nature of SSR, it disappears as it goes away. But because ray tracing just works, you just get the expected
result. It just works.
How you think you would see it. So the next
just
thing
works.
I show you
I like how this
is the big, scary crocodile tank, the Churchill. And if we make that one shoot, it's flamethrower across the scene here. Then we will again see that reflecting upon the surface and on the soldiers battling it out here in Rotterdam. So now if we look down in the ground, with RTX on, we'll see the flame, we'll see the soldiers moving, we'll see everything. And now if I turn RTX off, we lose everything. We lose all the detail, all the context of what's happening in the scene. But with RTX on, you just get a much more cohesive image and a better understanding of what's happening around you. So one thing we also
but that flame doesn't look that great. The flame, the actual flame, not the reflection.
Making sure the smallest detail is correct. And you can see even there, the flames are reflecting properly in the wood of this gun here, and in the windows in the back. Now, if I turn RTX off again, you lose.
Yeah, come on. On the windows, it wouldn't be like.
Yeah,
wow.
Really cool.
Now, Jonas, what you guys have done is all of your guns, all of the objects are modeled physically.
Exactly.
It's physically based. And so the gun has wood, which is diffused, is a dielectric material. You have metal, which is reflective, and the metal has substructure in it, microstructure in it, so there's some roughness in it. And so without doing anything at all, because it's physically based, we shoot a ray into that scene. It intersects with a triangle on that piece of metal on the site, and it figures out.
I like how there's no
generate another reflection ray.
I mean,
and it traces its way to the flame, which is coming by, and when it comes by, it accumulates on the surface. It shades it perfectly all by itself. Ladies and gentlemen, the magic of ray tracing.
Yeah, but the signs don't. See,
there's
no reflection on the signs. There's a reflection on the windows, a little bit on the doors, if you can see, but they're not on the signs of the stores or the
C-47 airplanes they've been shot down, they're crashing with their engines on fire. So now if we go over to the car here, and you can also see the flame reflecting in the car nicely over there. So if we keep
because
moving
it's super
forward,
shiny and polished, like every car
look down
in a
this
conflict.
reflective car
Yeah,
right
it wouldn't be dusty or anything.
you'll
No,
still
of
be
course.
able to see
Oh, look, it's
the
perfectly
plane.
polished. Yeah.
Yeah. If we move back here, we can see the plane reflecting in the car.
Yeah.
If I move this
Yeah,
lens
'cause
flare
Wow, your lens flare works
right there,
good.
yeah. And then with RTX off,
I love
lose
it.
everything of it.
Yeah, look at that.
You can keep moving forward.
Wow.
Seriously, if you could get a car that shiny and reflective in
And
the
Jonas,
middle of
you guys did a great job
you know,
with Fresnel reflection. Look how
war
look,
zone.
when the angle is just right, it's just a perfect mirror. It looks
Exactly.
beautiful.
So here it's a good example on transparent surfaces with Fresnel and PBR rendering. The more of an angle you're at, the stronger the reflection gets. And now with what we had before, on these ones were just cube maps, which they're also static, but with ray trace you get a lot more detail. You see the entire environment. And of course, as I said, the old school cube maps, they are also static. So say that we were to destroy this building here, make a tank shoot it, with ray tracing on, you'll be able to see frostbites and Battlefield's destruction system within the window, moving dynamically. And now, to end it all off.
Okay, that's cool. Seeing the
RTX,
obviously
I mean,
it's cool
it
seeing the
works on entire
reflection. That,
scene.
you know, if
So
it's
what if we were to shoot off a V1 rocket here and zoom out, get a good view of the entire street of Rotterdam, and then take a look at the windows, all the places that you would expect to reflect. So now turn up the time again.
I would expect everything
Just
to
wait
explode and blow up if
patiently.
there's going to be an
Down.
explosion there.
And
Like,
there.
like I would expect the windows to. Okay, they're breaking. Okay.
That's awesome.
Kinda.
That's great.
Good job, you guys. Good job. That's really great. And
Thanks
it's
a lot.
amazing what you guys did so fast. I know you guys worked super hard, but it's amazing how you guys implemented this stuff so fast. I mean, that's one of the benefits of ray tracing. You know, the benefits of ray tracing is because things are going to behave physically. You should be able to turn things on. If the rest of your system and your models are done properly, you could turn these effects on relatively easily. I mean, it still takes a great
Yeah,
deal
especially
of
that
engineering,
hotel sign,
but comparing to doing
super
it
lit.
the
Although
traditional way of arting everything
lights
into
should be.
existence, the amount of engineering that has to be done is just significantly lower going forward. You know, hopefully, using the laws of physics, when you guys create a scene, things would just look right and behave accordingly. And so this is really just such a great achievement. Wow, things are still falling
Whoa,
apart.
that broke like heck.
I've never given
that
a
thing
copy
that
of total
fell is like it
destruction before.
broke touching
you guys
the
do
anyway.
destruction great. You're great at destruction. That's a lot of pent-up anger there, sir. Lots of great destruction. Okay, you guys made an amazing trailer. Let's take a look at it.
Okay, let's see the trailer. I guess they unveiled the GTX. How about the TI? No, they haven't unveiled anything yet. They're just showing games that use RTX. Not yet. Nothing yet. They're just showing really, really shiny cars in the middle of an armed conflict that reflect everything in the world around them. Which is like, yeah, no cards yet. No cards yet.
Wow, you guys killed it. You guys killed it. Real-time ray
Only
tracing.
impossible imagery.
Battlefield 5.
Mm.
And we have a great surprise for you today. Battlefield 5.
Don't you want to pre-order it?
Open
It's coming.
beta September 6th.
Okay, so what? Oh, he announced when the beta comes.
Guys, congratulations
Available
on a great
for
achievement.
everyone. Early access.
Yeah, this is really a wonderful achievement.
Okay.
Thank you.
I thought they
There
would
are
be
so
giving
many
away
other
the
RTX games
the
coming
game
your
with
way.
the
Developers
cards.
all over the world are working
Like?
hard on RTXing.
Okay, let's see. Control, Dauntless. That's
We're gonna
cool.
have
That's
all kinds of amazing
in
games coming your
depth.
way.
Final
Well, I guess
Fantasy
your question is
15,
this.
the Forge Arena.
What are you going to run it on? What are you going to run all these amazing games on?
On an $800 card, yes! Yes! The more you buy, the more you save. Oh Jesus, what's with the music? Come on. Alright, shit, okay. Okay, so 11 gigabytes. Okay, so that's dual 13 blade axial fans, 13 phase. Okay, so they're dual fans for the TI. So this is the TI. So this is the DP 1.5A Virtual Link VR, well, reconfirmed. GeForce RTX 2080 Ti. This is it. This is it, everyone. Finally. Finally. Okay, I always like these explosive stuff. Okay, finally.
Ladies and gentlemen.
Oh no, it's the 2080? Wait, it can't be the 2080.
The GeForce
Oh, that's the 2080, but
RTX
it's on the TI.
20 series. Computer graphics reinvented. Isn't that beautiful?
Yeah, the more you buy, come on. I mean, I like the look.
The craftsmanship
I
is
can't say that I don't like the
unbelievable.
look.
The craftsmanship is unbelievable. This is the best design we have ever done. Everything from the voltage, the power regulation, and the thermal management system, it is designed for overclocking. Crazy amounts of overclocking. Not to mention, it is
How much?
so quiet. Even when you're maximum overclocked. At maximum overclock.
Like what?
At maximum overclock.
Like what would be the maximum overclock?
It sounds like 1/5 the audio levels as a 1080 Ti. It is so quiet.
Okay.
The engineering is just absolutely incredible. We're announcing 3 models today.
Okay, so 2080 Ti, 2080. Okay. Let's see. 45 RTX ops, so 78 for the TI,
The
60
RTX
for the
2070 with 6 gigabytes per second, 5 times that of a Titan X. 5 times that of a Titan XP. 45 trillion RTX ops per second. 45 trillion RTX ops per second. That is several times the performance of a Titan X. 8 gigabyte frame buffer.
Okay.
RTX 2080, 8 gigabytes per second, 60 trillion RTX ops, about 6 times the performance of Titan X for ray tracing, 8 gigabytes, and then the RTX 2080 Ti, 10 gigabays. I love gigabays. 10 gigabays.
I love them gigabays. So it's 6, 8, and 10 gigabays. Okay.
78 trillion RTX ops, 11 gigabyte frame buffer. Starting at $499.
Okay, so it's got the 2070 is $500. So a new high for the 70 cards. $500.
Pre-orders today.
$500 from, and I remember getting my 970 for what that started at $329, and now it's $500.
Everywhere, September 20th.
Okay. Jesus Christ. Jesus freaking Christ. No, it's 5. It's 0. It starts at 500, not 6.
The NVIDIA RTX family.
Well, say the
NVIDIA RTX family. Ladies and gentlemen, soon I'm going to see the NVIDIA RTX family.
Not okay.
The NVIDIA RTX
so $499,
Quadro 8000,
$699. Wow.
RTX 8000, 2 GPUs connected by NVLink, turning it into one large virtual GPUs.
Jesus Christ.
96 gigabyte frame buffer, 166 trillion RTX operations. 166. 166.
So
That
now
is
the
basically
TI
16
model
Titan X's
1000,
in one PC.
which was the, you know, the Titan level pricing.
Now just imagine, that is twice the ray tracing performance of a $68,000 DGX station. Twice the performance of a $68,000 supercomputer.
So that's $100 more for the compared to the 1080.
The 2080 from $699 and the 2070 from $499, and the 2070 is higher performance than the $1,200 Titan XP.
Okay. Okay, so the Titan XT is gonna be like 1,300 probably, or something like that, or $1,400 or $1,500. Crazy.
I want you to look at it this way.
Nah.
Look at this.
Yeah, sure.
This is what
the more you buy, the more you save.
The biggest generational leap in the history of computer graphics. Our beloved Pascal, the best GPU the world had ever seen, next to the Turing family. It is a shocking contrast.
I'm looking forward to reviews.
10 years in the making.
Yeah, but it's
so, ladies and gentlemen,
it's RTX ops, right?
So proud of it.
Shut up, you shut up.
Well, that's our show. The GeForce
Hey,
RTX,
that's our show. Well, that's a shitty presentation with like very short.
The first to implement the NVIDIA RTX platform, reinventing computer graphics using this hybrid rendering mode of rasterization and ray tracing, compute using CUDA and artificial intelligence. Artificial intelligence that was trained using supercomputers, and all of those neurons and all of those weights from all of that experience then sits inside your PC, and it generates images that no possible software written by humans could do. And it generates beautiful images. The Turing, the largest generational leap in the history of our company. The most important new GPU we've created in 10 years since CUDA. 78 tera RTX ops. 78 trillion ops. Basically changing things so dramatically, we have to change the way that we talk about performance. Because in the future, you're going to...
Yeah, because we don't have the performance with the old metrics.
You're going to use post-processing on some of the image, and you're going to use artificial intelligence to generate all kinds of pixels that are impossible to generate otherwise. And the GeForce 20, the GeForce RTX 20 series, starting at $499, available everywhere on September 20th. What do you guys think?
That we'd like some specs at least. Not even specs. We didn't even get specs. We got the RTX ops crap, which is like we're gonna add this one up and this one up and this one up, and it's like all okay. But how many games will take advantage of all that?
The guys did something.
All right.
Well, everything is real time. It's physically based. All the materials are modeled properly. Reflections just work. Inner reflections just work. The lighting just works. Ambient occlusion just works. Area lights just works. Have I told you that before?
Everything just works.
Lighting,
everything works.
reflections,
Yes, I know.
shadows, it just works. Everything could be dynamic. No cooking necessary. No art necessary. Just turn on the lights. Enormous amount of computer graphics capability then kicks in and draws the rest of it. Everything you see here is all completely in real time. Ladies and gentlemen, have a great Gamescom. It's been a pleasure being with you. This is a historic moment. Computer graphics has been reinvented. Thank you very much. What do you guys think?
That we'd like some specs at least. Not even specs. We didn't even get specs. We got the RTX ops crap, which is like we're gonna add this one up and this one up and this one up, and it's like all okay. But how many games will take advantage of all that?
The guys did something.
All right.
Well, everything is real time. It's physically based. All the materials are modeled properly. Reflections just work. Inner reflections just work. The lighting just works. Ambient occlusion just...
That was the event. So that was like an hour and 50 minutes of talking and showcasing some games, and 5 minutes of actually talking about, you know, the actual talking about the actual cards and what they have. So $100 for the 2080, and for the 2070 $500. So that's 100 more than the base prices of the 10 series. So 2 years later, 2 years later, gotta pay more for the same tier. So yeah, that's interesting. And they're cheap, yeah. And you know what? It really pissed me off that there's no specs. It's like, I like how, you know, Jensen said that, oh, you know, the rumors online, you can say that they were all untrue. Like, what was untrue? First of all, I mean, nothing. So that was a big call, like a big nothing burger. We didn't even get the numbers for how many CUDA cores. We got the gigaarrays. Okay, so in gigaarrays, because see, that's the thing, is like the gigaarray part, that whole co-processor, right, that has to be used for specific things, right? And unless an engine, you know, a game takes advantage of that co-processor, then those gigaarrays are space, like empty space, that's not going to be used on your chip, and you pay for it, obviously. So 10 gigaarrays for the 1080 Ti, 8 for the 2080 Ti, 8 gigaarrays per second for the 2080, and oh, shut up. Yeah, they're not saying anything interesting, so it doesn't really matter. So it's 10 gigaarrays, 8 and 6 going down, and in terms of RTX ops, 78, 60 and 45 going down, you know, Ti 80, pure 80 and 70. So those are high prices. Officially the GeForce X80 Ti has reached the level of Titan cards, or at least former Titan cards. So yeah, this is pretty freaking expensive, and I don't know. To me, it's disappointing. You know, people could say, like, I'm sure there will be people online say like, oh, just get a job or something like that, like whatever, like peasant and stuff like that. But you know what? The prices have been going up, and you know, I like how, you know, Jensen said that he liked the GeForce GTX. I mean, if we take the GeForce GTX to the GeForce 256, it wasn't the GTX by then. There was nothing like that. The GeForce 256 SDR, and if we take its price and we go with we calculate the inflation, I'm willing to bet that it's not going to be $999. So let's see, NVIDIA.com. Can we do anything here? Can we wait? United States. Let's go to United States. Can we find the keynote? I don't care about the keynote. Can you pre-order stuff or what? Shop. Let's go to the shop. The available GTX don't seem to be here. The world's first race tracing GPU. Okay. No, they don't seem to be up. So yeah, that was the announcement. Very disappointing when it comes to the actual freaking hardware. And when I say the actual hardware, I mean CUDA cores. Like what the fudge are the RT cores? Like a little bit about them. Like what the fudge do they do? How do they look? How much space do they take? That would be a little bit. That would have been nice. Like how much memory? How much memory? How much bandwidth? Nothing like that. And it's all of that could have been one freaking slide show, slide picture. So sad in that regard. I thought they flew over some pretty important things, and again, all the Giga Rays and the RTX ops, all of those matter if the software takes advantage of them. If not, then you'll have, I don't know, more than 50% of the core of the GPU like not doing anything, because the software, like what does the software, like take a 2D game, maybe not a 2D game, let's say take a 3D game that doesn't do ray tracing, then the Giga Rays will mean nothing, right? Unless that co-processor can be used in other places. I don't know, we'll have to see, but for now I'm disappointed by the prices. Not that surprised, but a little bit disappointed. Again, everyone, RTX 2080 Ti $999, 2080 $699, 2070 $499. So yeah, high prices, apparently sold out. Anyway, available on shelf apparently September 20th, so it's going to be more than a month. Actually, no, a month until they're available. And from all the leaks that have been coming out, there will be lots of models. Custom models from partners, from Asus, from MSI, from Gigabyte, all those people. So EVGA and all that. So you can expect those more expensive than the prices I just mentioned. So for a 2070, just prepare to pay like $600 or something like that, like $550, $600 for a 2080. $750, $800, and for the 1080 Ti, $1,100, $200, or $1,200, which is anyway out of my budget. But if you can afford it, anyway, that's we need some more competition. AMD, come on, well, they're not gonna come out with anything just yet. But that was it. Thanks everyone for watching, for being here with me for the stream. You can comment below what you think about the prices and about the cards. Very little info, seriously, very freaking little info, like on the actual hardware, which is, anyway. And we only saw one card. It's like, do they all look the same? It's like the virtual link, no word on the virtual link. Like, does that not matter at all? Because that's a thing on the freaking card. It's quieter than the all models. Okay, well, it has two freaking fans. Okay, great. You can spin them slower than one. They have two bigger fans that spin slower than one smaller fan in the older models. Okay, congratulations. So, everyone, thanks for watching. If you like this live stream, please give it a thumbs up and subscribe for more. I usually cover games. Well, I cover only games, but hopefully we'll get to see more hardware in the future, and I'll see you again tomorrow. Thanks again, and until next time we see each other, have an awesome day.